All right. Well, good morning and happy New Year. And I just realized I have the wrong day of the week here, but it's Wednesday. and um, yeah, happy Lunar New Year to those who celebrate. Let's take a look at what we'll look at today. We'll look at dplyr. Okay, and dplyr is great. It's a great package for data wrangling. So it's part of the tidyverse. So again, covering several packages out of the tidyverse. We looked at tidyr and how to pivot our data to get things into tidy form, and we're going to assume our data is now in tidy form. And once it's in tidy form, then it will work really great with dplyr. Okay, so again, tidy form is, you think about how you want your variables arranged, and you want your variables to each have its own column. Okay, and so once you have the variables arranged the way you want, so you pivoted them to either be long or wide, however you need, so that whatever variable you're working with appears down the columns. Okay, and then once you have that, then you can use dplyr. And to get dplyr loaded up, you call library dplyr, or you can load up the entire tidyverse, and that's done with library tidyverse. Okay. So when we work with data, this is what we have to do. Okay, and this is going to be the case whether you're using dplyr or not. Is you have to figure out what it is you want to do, and then you have to take what it is you want to do and turn it into code. Right, and that part is often a little bit can be challenging depending on the tools you have, and then you run the code that you have and you make adjustments as you need. And dplyr gives you what I would call a constrained set of functions. So you get these certain kind of building blocks, and you chain them together. You put them together to accomplish what it is that you want, and dplyr in that way works. Okay, and the way you're going to structure your dplyr commands is we're going to use something called the pipe, and that makes your code more readable and easier to understand, because the way you end up writing it looks like kind of a step-by-step thing rather than a bunch of nested functions. So these are going to be kind of the primary set of verbs that you will be using: select, filter, mutate, arrange, summarize, along with group by. Okay, and these are going to be the verbs that you use. And so we use select to select columns, filter to keep just the rows we want, mutate creates new variables, arrange sorts them in a certain order, and then summarize aggregates or calculates summary statistics. And so those are the verbs we're going to use, and then we pair them up with group by to get the numbers that we need. Okay. Handy thing is this cheat sheet that you can get. So I recommend this. I think you can just look up RStudio or dplyr cheat sheet. That'll probably be one of the first hits. So they have kind of a bunch of different things that you can do. All right, so we'll work through dplyr, and we'll kind of learn how to do it via example. Okay, so the data set we're going to look at is called the Star Wars data set. It's included in dplyr. This data set's, I don't know, like a dozen years, or I don't know. When did the data set was produced between The Force Awakens and what was the 8th movie? I don't remember. What? The Last Jedi? Okay. All right. So it came out after the 7th movie, and so it doesn't have movies 8 and 9 and things like that. And basically, it has information about all of the named characters that appear in the movies. Okay, So, Luke Skywalker, and it has, the height, height in centimeters, weight in kilograms, or mass in kilograms, hair color, skin color, eye color, birth year. There's like sex and gender and things like that. Again, time being a numeric variable, you have to kind of pick an arbitrary point in time. And so I think in the Star Wars universe, their year 0 or year 1, whatever, their epoch is the Battle of Yavin. This is like getting out into the woods of nerddom, but it's when the Death Star blows up in the first or the fourth movie, whatever. The first movie, the fourth in the series. Okay. Sorry, I spoiled the ending. The Death Star blows up, but I think you guys know that, and so that's considered their epoch. And I guess Luke Skywalker was born 19 years before that, and so his birth year is 19. It's like human years, 365 days. I don't know how this works, right? They're revolving around. Okay, but anyway, so yeah, C-3PO 112 years before that, whatever. Okay. And anyway, this is the information we have. One of the things we're missing is like the species and stuff like that. And so anyway, you can see more details. There is a function called glimpse. It's kind of like str, all right? And what it does is it gives you kind of a compact overview of the data. Right. A way you can think about glimpse is, most data sets, your variables are in columns and you print them out and you have a whole bunch of rows. And glimpse is, you can almost think of it as like transposing your data set. So the variables get printed out across as rows. All right. And you can just kind of see the data this way. All right. And so we have 87 rows, 14 columns, and things like that. So we have 14 different variables: name, height, mass, hair color, skin color, eye color, birth year, sex, gender, more and more and more. Okay. So, okay. And then, and so anyway, we can select columns using select, okay? So the select allows you to choose whichever columns you want, okay? When you use select, you don't need to put quotes around the column names. So we can just select, I want to select the column name, homeworld, species, films. I don't need to put quotes around them unless you have like a space in the column name or something like that. Special characters, you got to do that. So the way this works is you say select from whatever data frame or tibble you're dealing with, and then the columns that you want, okay? From here on out, I'm going to write all of my commands using the pipe, okay? The pipe operator. And the pipe looks like this, and it allows you to pass the result of one function directly into the other. And what it does is it passes it in as the first argument. So x pipe into f of y is equivalent to writing f of x, comma, y. And so this previous slide right here where I said select from Star Wars, name, homeworld, species, films, this is going to be presented this way. Star Wars gets piped into select, and then from select, name, homeworld, species, films. Because all of the functions in dplyr, the first argument is always going to be whatever tibble or data frame you're working with, okay? And so you can take each of these functions, take in a data frame, and then output, or take in a data frame or tibble and output a tibble. And so you can chain these functions by saying like, okay, once you do this operation, it outputs a tibble, then pipe that into the next operation. So you take that, whatever tibble the previous operation piped out, gets piped into the next thing, it does something, pipes out another thing, and you can kind of chain all of these things together. And so you're going to see a bunch of functions being applied, and and you're gonna be seeing them chained using the pipe. Okay. The shortcut to insert the pipe is Control-Shift-M or Command-Shift-M in RStudio, so you can use that to enter a pipe. And depending on your settings, the pipe might appear like this, percent greater than percent. This is the Magrider pipe. This is kind of the older version, and the newer version looks kind of like this. Okay, this still works. But this would be the preferred form. This is the native pipe. Okay, so we can select columns just by kind of like naming them, right? Other things you can do, you can also put in a negative sign in front of the column, and that will deselect them. So I could say select from Star Wars, or Star Wars select everything but the name, eye color, and birth year. And we get the other columns: height, mass, hair color, skin color, sex, gender, homeworld, species, films, vehicles, and starships, and what they look like. And so the droids, like C-3PO and R2-D2, are sexless. They don't have a sex, but they are gendered, and so their gender appears here masculine. Here I use the function print with Tibbles. You can specify print n equals 6 or something, and this will just print the first 6 rows. I recommend, when you're working with Tibbles, I recommend using print with the argument n equals versus head, because what head does, head will just return the first 6 rows, so it feels like, oh, well, that's the same, right? If I do head, and you specify the number head 6, that will give you the first 6 rows. Here I say print n equals 6, and it gives me back this first 6 rows. The difference, though, is that print n equals 6 retains the entire dimensions of the table. So you can see it says a Tibble 87 rows by 11, and it prints out the first 6 rows, and it says there's 81 more rows. Or if I did head, okay, so if I copy this? All right, so I'm gonna copy this. All right, but if I did head, it's gonna just, the output will be a table with only 6 rows, okay? And you won't know the actual dimensions of the entire table. Whereas print n equals 6 retains that information about how many rows there are. So let me just demonstrate that, but perhaps on the next slide here, okay? Similarly, another thing you can do when selecting columns is you can use the colon, okay? And you can select a continuous range of columns. So you can say select all the columns from name through eye color, and it selects those columns, okay? And in the order that they appear in the data set. So let me call library tidyverse. Okay, and then we're gonna run this. So you'll see here, I get, it says 87 by 11, 81 more rows, versus if I say, if I do head 6, okay? Now it says a Tibble, and there's only 6 by 11, okay? So I prefer n equals 6 because this information, how many rows there are, is useful to us, okay? That's useful to know how many rows you end up getting after you do some kind of operation. That's useful, so I prefer print n equals 6, okay? And that's gonna tell you how many rows you have, even if it's just, the first couple rows. And you can even do like n equal 1. It'll just print out the first row, but however much you want. And then, if you specify like 50, it will print the all 50 rows. And then if you don't specify anything, then it uses the Tibble method, which figures out how big your screen is and tries to fit things accordingly. And by default, it'll print kind of like your first 10 rows and stuff, okay? And here it says, one more variable, starships list. If I make my screen bigger, I think it'll be able to fit everything. Okay, and we get starships there. Oops, it's not the one button I want. All right, okay, so colon notation, you can select a range of columns. We also have these helper functions, okay, and these help allow us to select columns dynamically, and you can look up tidy select helpers for more information. But basically we have contains, so basically columns that contain a certain string, columns that start with a certain string, columns that end with a certain string, okay? Or columns that match a particular regular expression, which we will we'll cover in our next lectures. Everything, this will select all of the columns, and that's useful if you needed to like reorder columns and things like that. Numeric range, if you have columns named like x1, x2, x3, x4, x5, something like that, and then one of, you can select columns stored in a character vector. So here I'm going to say select all the columns that end with color along with name. So we're going to get the name and then hair color, skin color, eye color. This seems kind of silly, but this is a regular expression, $, which means ends with an S. Now I realize I could have also just done ends with S, but this is a regular expression. But and we'll learn more regular expressions, but this one picks name along with anything. So we have mass, species, films, vehicles, and starships. And we have that, okay? And then sometimes you will have a vector of column names, okay? So as you're working, you might create like some vector with a character vector with different column names, and you can use this to specify which columns you want to do. And so you can do select all of, and then you provided the vector, and it will select those columns, name, mass, and height. Okay. We have two of these functions. We have all of and any of. Okay. If you have something in here, and it's a name that doesn't exist, okay, all of will produce an error if it's missing, whereas any of will just keep going. Okay. It'll get as much as it can, and if you specify columns that don't exist, it's just gonna it'll just keep going. Okay. All right, let me give you your first view quiz answer today, which is the letter D. D as in dog. D as in dog. Okay, filter allows you to select rows based on a condition, and it keeps only the rows where the condition that you specify evaluates to true. The condition that you specify must be a logical vector with a length equal to the number of rows in the data set. Generally, this is not a problem because usually the logical vector that you specify uses a column, and the column is treated like a vector, and that vector is going to have the same length as the number of rows, and then you do something like this. So you can say filter name equals R2D2, and so it's going to, through the column name, take that vector of 87 values, produce a logical vector, whether the name is equal to R2D2 or not, and so you get 1 true for that row, and then false for everything else, and then this is what you get. But you could also provide it a separate logical vector from some other kind of calculation, and as long as it has the same length as the number of rows in the data frame, it can be used there. Okay. You can apply multiple conditions with filter. So a comma is equivalent to using and, okay, and then the vertical line is the logical or, okay? And so it'll keep rows that meet at least one of those conditions. So here I'm going to say filter species %in% human droid. So species needs to be human droid, and height needs to be under 175 centimeters. And then I'm just going to print the first 3 rows. And this is where print versus head is useful, because we can see there's 14 rows that match. Okay, and I only printed the first 3 just so it can fit on the slide here. Okay, but we can see there's going to be 14 rows that match. And again, here we're going to keep only the rows where the species is going to be human or droid. And then if you look at the height, it has to be under 175. Now, you could write it this way, Star Wars filter, and then you could do species equal to human or species equal to droid. Okay, so remember, if you don't specify species equal to droid and you say human vertical line droid, what's it going to do? It's going to try to coerce anything into a logical value. Okay, and anything that's other than 0 gets coerced into true. And so, oh, I did something. All right, and then this is also height is less than 175. Okay. You can also filter with, say, regular expressions, which, again, regular expressions super powerful, and that will be in a future lecture. But for now, there is a function that you just need to be aware of called string detect. Okay, and string detect will return true and false depending on whether it finds a match to the regular expression I provided. Okay, so this regular expression caret to f means starts with a capital F, and so if it detects that, it'll return true, and if it doesn't, it'll return false. And so here we're gonna ask it to check the name, see if the name starts with a capital F, and it returns true just for these 2 rows, and so it filters down to these 2 rows. Okay. And so if you have some other kind of more complicated data set and you want to search for certain kind of things, you can use filter and string detect. All right, so here is an example where we are going to combine functions using the pipe. And so we chain multiple dplyr functions using the pipe. Basically, we take the original data set Star Wars, we apply this filter. After we apply the filter, we apply the select, okay? And so it's going to take the output of filter, which reduces it down to 39 rows, and then from there we tell it we only want these 5 columns or something like that. Okay, so we're going to select only the characters with no hair. Okay, hair color is none, and then or characters with black eyes. Okay, so we have Darth Vader, who has no hair, and then Greedo, which I guess they weren't sure what was on his head, so he gets a missing for hair color, but he had black eyes. Okay, and then this is a robot, a droid. I don't know who these people are, or character, or whatever. Okay, these are bounty hunters. I don't know. Okay, and then we said we want these columns. Okay. Sorting rows with a range. So we can also take the resulting output and sort them, okay? And the default is whatever variable you put in, it's going to sort in ascending order. And then if you want it to go in descending order, you just wrap that variable with descending order. So here we're going to say from Star Wars, select these columns and then arrange them in descending order by birth year, okay? And then by mass in ascending order within each birth year. So Yoda, birth year 896, Jabba the Hutt, 6, these are conveniently evenly. All right, so apparently, I don't know who this person is, but Qui-Gon Jinn, Ki-Adi-Mundi were born in the same year, okay? And what is this? Okay, anyway, so sorted in descending order by birth year, and then sorted in ascending order, within the birth years, okay? Apparently, Klieg, Lars, and Palpatine are the same age. I don't know. This, I think, is... I used to really be into Star Wars until I was in college, and then I don't know what's happened since the 6th movie or the 7th movie in release order, but anyway, I think this guy is the like Darth Vader's mother's caretaker. I don't know. maybe someone will correct me. I'm sure. Put it in the comments. All right. Select rows by position with slice. Okay. So slice will select your rows based on the row number. So this reduces the resulting table, kind of like head. Head will crop it to just like the first 6 rows, and slice will just slice it to whichever rows you specify. So I say I want rows 5 through 10. So 5 was, oh no, that's in the original. Okay. In the original data, do I have it? Okay, so this is the original data. We're going from Leia Organa down to Obi-Wan Kenobi, all right? And so slice, we get from Leia down to Obi-Wan, okay? And this is what we get. You can also randomly sample rows with slice sample. Slice sample is going to select 5 random rows. And this is useful if you need to kind of preview a random portion of the data set. So, for example, if you do head only gives you the first X rows that you say. So you say head 5, you're just going to get the top 5 rows. And not that this is foolproof, but sometimes you've done some kind of operation and it works well for the first 5 rows, but then later on in your data set where the rows are different, okay, whatever operation you did didn't work well for like the later rows. And so slice sample is going to randomly select some of the rows. And so if something failed, you're more likely to kind of detect that with slice sample than you are with head. Okay? Again, because it's random, whatever operation you did might have failed on just 1 or 2 rows, and then slice sample is probably not going to select those rows. But if it's something where the operation failed on a whole bunch of rows later on, and you do slice sample, you're more likely to kind of detect that kind of problem. Okay, and then sometimes you just need a random subset if you need to do some kind of testing on certain test cases or whatever. Slice sample works there. Okay, we also have slice min and slice max. These will select your rows based on the smallest or largest values. Okay, so we could do, Star Wars slice max, mass n equal to 3, and this will pick the 3 rows where the mass is the greatest. This is equivalent to saying, slice Star Wars arrange in descending order by mass, and then select the top 3 rows. Okay, so slice max is kind of like this, but it gives you one simple command to do it, just because this is a fairly common enough operation that the authors said, oh yeah, let's give it its own dedicated operation. Okay, slice min does the same thing, but it selects the smallest ones. Okay, you can create new columns with the command mutate. Okay, so here I'm going to say basically take the height, divide it by 2.54, and create a new column called height inches. Okay, so the mutate allows you to create new variables based on the existing one. Now, when you do this, the new column gets added to the end of the data set. So when I say just print the first row, we get all of the things, and then you can say 3 more variables, vehicles, starships, and then the new variable I created was height inches, and that shows up at the end. So in this case, I'm going to run it again, but this time I'm going to specify which columns I want to select, name, height, and height in inches, and Luke Skywalker, 172 centimeters, or 67.7 inches. Now, when you use mutate, this new variable that you create must have the same number of rows or same number of values as there are rows in the data set, because it's creating a new column. So if the original data set has 87 rows, that new column has to have 87 values. Otherwise, it can't. It's, how do you, like if your new variable only has like 45 values, how do you pair that up with with your data set that has 87 rows? So you have to think and just make sure that your the column you are creating is going to have the same number of values as rows in the data set. So things that work will be something like the cumulative mean. Now the cumulative mean is stupid to calculate for this data set. So cumulative mean works best. Any of these cumulative functions, is this on? Work best when you have like time series data. Okay, so it's like in January it was this, and then in February the cumulative mean is this, and in March the cumulative mean is this, so on and so forth. That makes sense. It doesn't make sense because there's no ordering to these things, but just so you can see, right, if the first number is 77 and the next value is 75, then the running mean so far is 76, and then if we add in a 32, then the cumulative mean is going to be 61.3, so on and so forth. And so here this is creating a new variable, cumulative mean. Okay, I guess it's on, but all right. So these are some useful functions that we can use for mutate. We have row-wise or element-wise functions, pmin and pmax, and this will find the minimum or maximum for each row across whatever columns you've specified in pmin or pmax. You have cumulative min and cumulative max will keep track of the minimum or maximum value seen so far. Cumulative sum and cumulative product will be the cumulative sum or product. Cumulative mean will be the cumulative mean, okay? You have obviously all of your other logical functions, greater than, less than, equal to, so on and so forth. But another one that you have is between, and this will check if a value is between A and B. Now you could do this yourself. You could create x greater than A and x less than B, and you can do it that way, but this is just kind of like a handy thing there. And then we also have these offset functions, which will either shift the values forward or shift the values backwards, okay, lead and lag. And then ntile will take a column and then basically split them into equal-ish sized bins if it's able to, okay? And it will say like, oh, this is in the first quartile, second quartile, third quartile, fourth quartile, things like that, okay? So here's just some examples. These operations make no sense whatsoever to do on this data set, but it is just to illustrate what these functions are doing. So we're going to do cumulative min mass, and this is going to be like, what's the smallest mass value I've seen so far, okay? And so as we're going 77, 75, 32, and then once we reach 32, we don't see anything smaller. So that's the smallest value, smallest mass value we've seen so far. Again, a lot of these cumulative functions make more sense for time series data and not so much for a data set of people, okay? Here I've calculated the ratio, but I'm doing mass divided by the mean of mass. Okay, so I'm going to take all of the mass values, calculate the mean of all of them, ignoring any kind of missing values, and then we'll calculate this. So I think the mean ends up being right around 100 kilos, a little bit less than that. So 77 divided by that gives me 0.791, and so on and so forth. Okay. Mass year P min, okay? So this is, again, doesn't make sense at all for this data set, but it just says comparing these two columns, and again, you can provide a longer list of columns, give it, what is the smallest value, in this case, the minimum value in the row that it sees, okay? Or what's the maximum value? So between 77 and 19, which one's smaller? 19. Between 75 and 112, which one's smaller? 75. Between 32 and 33, which one's smaller? 33. So on and so forth, okay? And then lag 2 is going to just shift all of the values from mass year P min, okay? We're going to lag it 2. We're going to just shift them forward 2 rows. So you can do this. Again, these things make a lot of sense for time series data. So if you had like time series data and you wanted to say like, how much did it change from one month over the other, you could shift all of your values. You can lag them by 1 month, okay? And then you can do your comparisons and say like, okay, this is the percent change from this day to the next day, things like that, okay? For data set with people, these operations don't really make sense, but time series type stuff, they're great. All right, summarize. Summarize is really where dplyr starts to shine. Okay, summarize and group by. So group by is next. So summarize calculates a summary statistic for a data set. Okay, and you have to think about when you use a summary function. What a summary function does is it takes a bunch of values and it reduces it to one value. That's the whole point of a summary function. When you say, I want the mean, you're taking like 100 values and you're reducing it to one, okay? When you ask for the standard deviation, you take a bunch of values and you calculate one value for the entire thing. So a summary function will take all of the values. In our case, we've got 87 rows, and it reduces it to, say, 1. So here, I'm going to say from Star Wars, select height and mass, okay? And just using those columns, I want you to create these summary values. Give me the average height. So I say mean of height. Give me the variance of the height. Give me the average mass. Give me the minimum height. Give me the maximum mass. And then the count is just how many values are getting summarized here. All of these I put in na.rm equals true so that we ignore missing values, because I think you guys know if you try to calculate the mean and there's a missing value, then the mean ends up being missing. Okay. Now, you have to kind of think, does it make sense to ignore the missing values? Sometimes yes, sometimes no. Just for the sake of this illustration, I said let's ignore them, but that might not be the best move, right? Like if a family has 5 children and you know the ages of 4 of them, and then someone says, hey, what's the average age of the kids in this family? You have to say, like, I don't really know because I don't know how old the 5th kid is, right? But you can't just say, like, oh, I know these 4, or I know these 3 values, so let's just take the average of those. That doesn't quite work, right? Like, okay, so we have these compute the summary statistics, and then n counts the number, I guess, of non-missing rows. So if you had, well, I guess just the number of rows that get summarized there. Okay, here I'm going to call group by. Okay, now when you do group by, it doesn't look like anything happens. Okay, so group by doesn't change the data directly, but there is a subtle difference, and it just puts in this thing, groups, species, 38. Okay, that's the only real noticeable change. Here I said Star Wars group by species, okay, and it goes through this column species, and in the Star Wars universe, mostly humans, okay? At least the named characters, they're humans. You've got droids, you've got people from different planets. I don't know how it works, but yeah, there's no human homeworld. But then I don't know, like the Gungans are on Naboo, and well, anyway, okay. So anyway, you get these species here. So you have that. Okay. Now I can, if I pair up group by with summarize, now it calculates these summary statistics for each of the groups that it created. Okay. So I say, hey, give me the mean height, give me the standard deviation of the height, give me the mean mass, standard deviation of mass for these groups. And the default is when it looks at the groups, it's going to return the groups in alphabetical order. So you have the Alina species and the Basilisk species and the I don't know what these species are. We only have one instance of each of these things, so we get a mean. But if you only have one value, there's no standard deviation. We had 6 droids in the data set, so they appear as such. Okay. So I'm going to further add on a few more lines here. Okay, I'm going to say group by the species, then summarize. So now you can start seeing where the pipe is useful because it reads kind of like a step-by-step recipe. So we're starting off with the Star Wars data set. We're going to group by the species. Then we're going to create these summary values. All right. Now I want to select only the rows where the count is greater than 1. Okay. So I had all of these things where there was just one instance of that species. And now I want to get rid of those, okay? And then we're going to arrange in descending order by count, and then we will print out the first 6 rows. And so we have a total of 9 different species. I guess if it counts. All right, so we have 35 humans, 6 droids, I guess species unknown, 4 of them, 3 Gungans, 2 Kaminoans that were named in the thing, okay, in the universe, and that's what we have, okay. And these are the mean and the standard deviation of these values as we go on, okay. And so my hope is that you'll be able to start reading these things and understand what's happening without having to, it's not going to feel like a mystery with each of these things. So dplyr should have simple enough syntax for us to understand. Yeah, question?
Can you explain how the group by function works again? So does it put all the species together?
So it just basically it doesn't modify any of the data, but it just specifies these rows belong to the same group. These rows belong to the same group. So then when you do a summary function, so without any groups, okay, I have 87 values, and I say summarize, give me the mean, it's going to give me the mean of all 87 values, okay? When I say group by species, it's going to say, oh, I've got 38 different species groups. Now when I calculate the mean, I'm going to separate out the humans and give you the mean of the humans, okay? I'm going to separate out the droids. There's 6 rows for droids. I'm going to give you the mean of the droids. I'm going to separate out this, the Gungans, and give you the mean of the Gungans. And it does it for each of the different groups that you've defined based on some categorical variable. Okay, let me give you your second view quiz answer, the letter B. B as in bear. B as in bear. Okay. Group by can be paired with other things like mutate, okay? And this will compute new variables within each group, okay? So here we're going to just look at humans and droids, okay? Or the species is unknown. We're going to select the name, the species, and the height. We're going to group by the species, okay? So we're going to have 3 species, humans, droids, and unknowns. And then I'm going to mutate, and we're going to calculate the z-score of height. And height is going to be height minus the mean height divided by the standard deviation of the height, okay? But because I've paired it with group by, the height values, the mean height, is calculated per group, all right? So the z-score is computed within each species, and so a character's height is going to be compared to the mean height of their species. So one thing to note is C-3PO is a droid, and compared to other droids, C-3PO is above average in height, okay? Because you've got R2-D2 is short, C-3PO is tall, so compared to other droids, C-3PO is tall, he has a positive z-score, okay? If I do the same thing, okay, so same operation, but I just comment out the group by, okay? So now there's no more groupings, and now the mean is calculated for the mean of everybody. Standard deviation is calculated for the standard deviation of everybody. And so now C-3PO, compared to everybody in the data set, or at least everybody that for these rows here, C-3PO is below average in height, and so his z-score is negative. Okay, does that kind of make sense? Because when you compare combine group by with mutate, it's going to calculate new variables, but it's going to do any kind of operation like mean or standard deviation. It's going to do those things per group. Okay. Here's a toy data set, and you can create hierarchical groupings. Okay, so you can group by with multiple variables, and that's going to create hierarchical groupings. So here, this is a fictional data set. We've got countries A, B, C, Afghanistan, Brazil, China, years 1999 and 2000, sex, female and male. We've got this stuff, and then just some made-up numbers here. Okay, so I'm going to group by country and year. So it's going to create a hierarchical grouping, right? And so here, because I've grouped by country and year, it's going to say, all right, how many unique groups do I have? We're going to have 6. We got Afghanistan 99, Afghanistan 2000, Brazil 99, Brazil 2000, China 99, China 2000. Okay, and then here the summarize is going to just sum up those numbers. So it takes the 1 and the 1 and it creates 2 and so on and so forth. Okay, because of the hierarchical grouping nature, there still remains groups. Okay, I have 3 groups. Okay, because we group by country and year. These rows are still grouped by country. Okay, so I can take this result here and further summarize it and say sum up the cases, and it will give me the summary for Afghanistan, Brazil, and China. And then I could further, if I wanted to, I could further summarize it, and it's going to add all of those together, and we'll just get 24 cases in total. So each summary operation basically collapses another level of grouping. If I change the order, so here I change the order in the group by, if I say group by year, then country, okay, we still get 6 groups, but notice they are grouped first by year, so we're going to get all the 1999s, and then we get all of the 2000s. We get 1999 ABC, 2000 ABC, okay? And then, again, because of the hierarchical grouping, after I summarize, I have 6 rows here, and there's still a grouping level, and this one it's grouped by year, okay? So if I call summarize on here, I'm going to get all of the cases in 1999, all the cases in 2000, and then if I call summarize again, it collapses that level of groupings, and we get a total of 24. Okay, so that's I don't know why that guy disappeared, but that's how grouping works. Okay, I'll let you explore these slides on your own time. We're going to run out of time here, but we also have verbs in dplyr that allow us to combine tables. Okay, these 2 table verbs, and so these are basically joins. We have mutating joins, filtering joins, and set operations. But we're just going to kind of look at some of these join tables or join verbs, and you can learn more at this page, 2 table verbs in dplyr. And here I've got 2 fictional toy tables. Okay, I've got a people table, the names ABCD, Adam, Betty, Carl, Doug, and then the states are CACANYTX. Okay, and then here I have a states abbreviation table. I've got CANYWA, California, New York, Washington, and there's just one common key here. All right, we have the state abbreviations in the people table, and then matches can be matched to the abbreviation column in the states table. Okay, but I've intentionally have things that are missing exist in one but not in the other. So the left join, so here I've got, again, people and states. The left join will keep all the rows from the left table, in this case will be the people table, and adds all of the matching columns from the right table, okay? And anything that's unmatched becomes NA. So we keep all the people A, B, C, D, and we have matches for California and New York, or CANNY, but no match for TX, so that gets an NA. The right join keeps all the rows in the right table, so we have CANY and WA, and it adds matching columns from the left table. In this case, it's going to be people. People's gets piped into right join. So people's the left table, states is the right table. Right join keeps everything in the right table, puts in NAs if it doesn't find a match. Inner join only keeps rows that matches in both. So we have matches for CANNY, so we lose the row for Doug, we lose the row for Washington. And full join is like the union, and is going to keep all rows from both tables, and anything that's unmatched gets an NA. So it keeps Doug, but it has no match for TX. It keeps Washington, but it has no match for WA, so we get NAs there. And then you can control how the tables are matched using by. So auto match is going to look for columns with the same name. If columns have the same name, specific names, okay, or sorry. if the same name exists in both columns and you just want to use that one, you can do by equals this. And over here, because I had two different, the column name was called state in one table and abbreviation in the other, you have to use by equals, and then you say x is equal to y. Okay. And I recommend not using auto match and either using this one or this one, specific or different column names. Okay, let me give you your last view quiz answer, which is the letter A. A as in apple. A as in apple, and that will be it. Have a great day, and we'll see you Friday.